So I just have one more topic that I want to cover with you, which is an emerging area in fisheries management, which is what's called ecosystem-based management. So traditional approaches have been to say, let's set a total allowable catch, or let's regulate the amount of fishing effort. So we might, be familiar with some of those things where we have restrictions on when we can harvest things. Ecosystems-based management is, I guess, much more complicated than that. It's sort of recognizing the complexity of the system and really looking at the interactions within the system. It's going to be much more difficult to implement this kind of approach, but the idea is that we will take more information into account. So the various concepts, predator-prey interactions, the possibility of a calamitous event, all of these kinds of things that we might feed into a system. So I'm just going to run through with you how some of this might work. So we have a target population. So this would be whatever we're interested in managing. And then we're going to have to accept that there's going to be some catch. Okay. So now we start thinking about, well, what's the overall environment that this sort of target population sits in where this catch is going to take place. So the things that we then start to need to understand are, well, not just what happens with this target population, but what are the predator-prey relationships that we've got going on here? How are changes in this target population going to be impact the predators, so up the food chain, and how are they going to impact what's down the food chain? So we can't just look at a target population, we have to look up and down the food web to understand what's going on. So this immediately becomes much more complicated, but on the upside, it starts to allow us to think about, truly managing the system, or in managing it in a sustainable way, or picking up the things that we might be missing. So our target population, this is where we start to get on. Well, we're going to need some data for that. So that's the kinds of things that we, been understanding a little bit here. What would we use for our estimate of a population? Well, we would use, some data to estimate the mean, some uncertainty about the mean. So they would be our simple things. And we're also going to be looking at, well, what's going to happen when we have our catch? So once we start setting the catch, how is that going to change our estimates of population status? Is it going to be healthy? Is it going to deteriorate? What's sustainable? What's the maximum sustainable yield? What are the risks to that? How much has this population changed through time? What's the biological uncertainty? So all of these things are data in and going for the things that we get estimates of. We then need to think about what are the interactions. So here we've got, our predator-prey relationship. So again, we need to understand what's going on there. That's going to be our data-driven process. It's going to give us estimates of the interactions. So if we change our target population, what is that going to do to other populations? Are they going to be negatively impacted? Are they going to be positively impacted? What's going to happen? That's all going to be seeing these links coming back through. So then we're feeding back in this data into our system to manage the target population. So you can see there's this sort of iterative flow coming through the system. So we're looking at all of these things, and then what that's giving us is information to create our management rules and procedures. Okay, so we're making an assessment of the stock, we're making an assessment of the interactions, we're putting that all together, and then we're going to come up with a rules-based system to govern what we can do. So this is obviously a lot more complicated than looking at just the simple setup that we've looked at traditionally in managing these kinds of fisheries. A lot more work, but hopefully this is an area of optimism that this is. I'm not saying that this is, again, not saying this is a panacea or the solution to all problems, but it reflects our ability to perhaps do a little bit better in managing these systems. Now, I also want to, I guess, just show you some examples of, a quota. In this particular case, I've set a quota. That might be the final outcome. Overall, the idea is that we manage this in a bit more sustainable way. So the advantages, it's the recognition of all of the links, that we need an integrated management solution to this, the interactions in the system. That actually, for perhaps in many cases, the first time gets recognized in the management process. All of the disadvantages, well, it becomes complex and we have more uncertainty, we have more things to work with. And you can see all the areas that might come up for people might try and hide behind the uncertainty to get different outcomes or unsustainable outcomes because we can't be certain about something. So all of these things. We also need to be aware of hubris. We saw in the Grand Banks fishery that the science was wrong. Okay, so there's a tale. Well, we made some mistakes, so we can't be thinking that we will always get this sort of that our models are always going to work. Okay, our models are not always going to work, and we have to recognize that. We have to do better at building our models, but we have to not be overly confident in just saying, oh, well, my model, said it's safe to take this. Well, maybe there are some other things to consider in this. So how does this sort of play out, or how might we, start to think about, the data that we see, or when we're trying to look at these interactions? So when we're thinking of predator-prey interactions, you can see we've got two pathways. We could see a change in food types, or we could see a reduction in food intake. Now, a reduction in food intake could then come out in, say, for example, lower reproductive success. Okay, so if you had less, that's one natural response to a reduction in food. Well, we won't see so many live births in that particular population. So we can have a look at some of these. So these are sort of down in our Southern Ocean, down in here, and we can see an example where we see a radical reduction in the krill, the amount of krill. So we saw that krill was sitting there, very central in the food web, being both an input to many, many different species. And what do we see in here? So what we see that there's a change in diet. Okay, so we go from the krill being a large portion of the diet to eating something else. So we see changes in that. So we do actually see these interactions. So we see a change in krill. We see our penguin diet moving to other things. Okay, so that's and they're very similar. The amphipods are very similar kind of crustacean, small crustacean. So then we have our example for the other side, looking at reproductive success. So again, same setup. We see a reduction in the krill population. We see a radical reduction in the reproductive success in fur seals. So these are the kinds of things that we're trying to look at. Okay, if we change one thing, if we allow a catch for one population, how does that flow through and affect the other populations? What are we looking for? What are likely to be the outcomes? Are we likely to see, we change one part, is that likely to impact the population of another? Can they switch to another food? Are they? Do we look at these things? And this all goes then back into the decision-making process. So we collect some more data and it goes back in, and then we adjust our policy, and we keep doing this. So we have to constantly revise our policy in light of the new information that we get. And that's the end of this little lecture.